Hi everyone, we are going to solve 3.9 example 4 of our booklet on Bernoulli's law and pressure difference. An airplane's wing has a surface area of 92 meters squared. If the mass of the wing is 88.53 times 10 to the power of 4 kilogram and the air density is 1.29 kilogram per meters cubed, find the pressure difference between the lower surface of the wing and an upper surface of the wing. That's part A. Part B, if the airspeed just above the wing is 300 meters per second, what is the speed of air just under the wing? So it is very important to know what's causing the pressure difference between the upper surface and the lower surface of the wing. So if I were just to draw a wing in here, so the pressure difference, if I take the upper surface pressure to be P1 and the lower surface pressure to be P2, what's really causing the pressure difference? It is the weight of the wing. So delta P equals force divided by surface area. Yeah. Mm, Now, I can calculate delta P, the pressure difference between the upper surface and the lower surface, by just literally writing the force of, that's the weight of the wing, which is m times g, divided by the surface area of the wing. So in that case, delta P equals, I would sub in for the mass of the wing, 8.53 times 10 to the power of 4 kilogram. You don't really have to use the unit. And instead of G, I sub in 9.8. Surface area is given. It is in the right unit. It's 92 meters squared. If you sub in all the numbers, you're going to get 9,086 pascals. Good. So this is the pressure difference between the upper and the lower surface of the wing. This is P2 minus P1. Yeah. So the pressure at the on the lower surface is higher than the pressure on the upper surface. So this pressure difference is caused by the weight of the wing. So we calculated the pressure difference, and that's the answer to part A. B, if the airspeed above the wing is, so if you're given V1, the airspeed above the wing is equal to 300 meters per second, what would be the airspeed below the wing? So I'm looking for V2. To solve for V, if you're given the pressure or the relationship between the pressures, in this case it's a pressure difference, we're going to use Bernoulli's equation. I'm going to write down Bernoulli's equation, which is P1 plus 1/2 density V1 squared plus density times G times H1 equals P2 plus 1/2 density V2 squared plus density times G times H2. Because the wing is it's not that thick, so what you could do, you could say, look, the height difference between the upper surface and the lower surface is literally 0. So by doing that, you could ignore this part and that part of the right and the left side terms on density times G times H. You could ignore those parts. If you do that, again, the height difference is 0. So therefore you have a P1 plus 1/2 density V1 squared equals P2 plus 1/2 density V2 squared. You don't have P1 and P2 separately. However, you have delta P. So if I take P1 to the other side, I'm going to do that first. So you have a P2 minus a P1 plus 1/2 density V2 squared. And this is delta P. Yeah. And now if you take it to the other side of the equation, 1/2 density V1 squared minus delta P. So it's very important to have minus delta P on this side, equals 1/2 density V2 squared. Now, if you want, you could multiply both sides of the equation by 2 to in order to get rid of 1/2 in here. So if I do that, I have density V1 squared minus 2 delta P equals density V2 squared. Then if you want, you could divide both sides by density. This way you have isolated your equation for V2 squared. So 2, I have a minus in here, minus 2 delta P divided by density. That gives you V2 squared. So now if you sub in, you have V1, which is 300, and then square that minus 2 times the pressure difference, which I calculated in part A, 9,086, divided by the density of air, which is 1.29, you will have a V2 squared. And if you take the root of this, your V2 is equal to 275 meters per second. Because the pressure is higher under the wing, Bernoulli's law says the speed of the air should be lower under the wing. Remember, Bernoulli's law says the higher the pressure, the lower the speed of the fluid. Therefore, the speed of air under the wing equals 275 meters per second, which is less than the speed above the wing, which is 300 meters per second.